Yes, sir. No, sir. And if you're seeing
Yes,
this,
sir.
Yes, sir.
all right. Let's begin.
Yes, sir.
Right. So today we're going to do scientific measurement. That's the main topic, and we'll look specifically on density. All right, we'll look on density of objects. That is our topic for today. All right, so the objectives are to compare the density of different substances, compare the masses of similar amounts of different substances, and finally, which we hope to do by tomorrow, compare the density of different types of substances. All right. So density. Have you ever heard the word density before? What comes to mind?
Yes, sir. I heard the word before.
All right. What comes
Yes.
to mind when you think about density?
Sir,
All right. When you say, for example, object A is more dense than object B, what do you think that would mean?
Heavy. Sir, it's more harder or softer.
All right. So
Yes, sir.
it is harder and it is even more heavy. All right. So that is
Yes, sir.
essentially what density is all about. The hardness and the weight or mass of an object, comparing those two and essentially the size that that object takes up. All right, so density takes all of that into consideration. When we think about the mass, what do we think about?
Sir, I think about the amount of matter in an object.
All right, so whenever we talk about mass, we talk about the amount of matter in an object, and for volume, what we talk about. When you think about volume, what comes to mind?
The amount of space.
All right, so volume, exactly. So volume is essentially the amount of space that an object takes up. So density would be the quantity that we use in science to compare these two quantities. All right, so we use mass, we use density to compare the mass of an object to the volume of that same particular object. So the formal definition of density is that it is the relationship between an object's mass and its volume. All right. So this is our formula. Density is equal to mass over volume. All right. Let me get my pen here.
Yes, sir.
Yeah. So it is essentially equal to mass over volume. So as you said, it is comparing those two particular quantities. So let me just set this up quickly. That's what density is all about. So density allows us to compare equal volumes of different materials. All right. So say we had 100.
Excuse me, sir. Can you tell that person to mute their mic because they're disturbing you and I cannot hear?
All right. I believe your mic is the only one that's open now. All right. So I think they turned it off before you made that. You said that. All right. I think their mic is off now. Yeah. Let me check. Yeah, their mic is off now. Good. Yeah. So which of the following will be heavier? 100 feathers or 100 pencils? Which one will be heavier?
Sir, 100 pencils.
100 pencils.
All right, so 100 pencils will be much heavier than 100 feathers, even though it's the same amount, and they probably will take up the same amount of space, right? You'll find out that the pencil, therefore, would be more dense or less dense than the feather.
Yes, sir.
Yes, sir.
Which should it be? The pencil is more dense than the feather, or the pencil is less dense than the feather?
Sir, the pencil is more
Sir, it's
dense.
more dense.
All right, so the pencil is more dense. So back to this density, right, which we put it as this form, as this symbol here. This is a symbol for density. All right, is equal to mass of the object divided by the volume of that particular object. All right, so when you compare the masses of blocks of the same size but of different materials, we are comparing the mass per volume, right? So this is the mass per volume. That is essentially the introduction to density.
Yes, sir.
All right, so are we all clear?
Yes, sir.
Yes, sir.
Yes, sir.
All right, anyone don't understand density so far? All right, so I take that as everyone is okay. All right, so let's
Yes,
move
sir.
on. So gases have very low densities because the gas, right? Because the particles in a gas, they are spread out. All right.
Yes, sir.
So
Not cold.
even
Yes,
a
sir.
large volume of gas will have a very small mass. All right. So this is the reason why. The reason for this is that the particles in a gas are spread out. All right. Liquids will have higher densities than gases because the particles in a liquid are much closer. So if you have 100 centimeter cubes, this is the unit for volume. 100 centimeter cubes of water of, let's say, all right, let me put this in the middle. 100 centimeter cube. So this is water, 100 centimeter cube of water is heavier than 100 centimeter cubes of gas. Right? So liquids have higher densities than gases because the particles in liquids are much closer. All right, so the metal mercury, right? Mercury is liquid at room temperature, and it is the highest density, right? It has the highest density of any liquid at all. Mercury, all right. So metal mercury, it has the highest density of all other liquids. All right, so solids have the highest densities of all because the particles in a solid are closely packed together in a lattice. All right,
Yes.
so
Yes,
structures
sir.
Yes, sir.
structures are usually represented as in lattice. All right, you'll find that structures are represented like this, or for example, crystals. But solids will have the highest density because they are closely packed. So 100 centimeter cubes. Let me adjust this. Right? 100 centimeter cubes of solid is heavier than 100 centimeter cube of water, which is heavier than 100
Yes, sir.
centimeter cube of gas. All right. So
Yes,
materials
sir.
that have density less than water, right? Like a cork, you know, like if you have a cork and you put it on top of the water, it will float, right?
Yes, sir.
All right, so a
Yes,
cork will
sir.
float while materials that have density more than water, like for example, lead or your pencil, right, has a higher density than water, it will sink. All right.
Yes,
So,
sir. For example, if you put a stone in water, it will sink.
right. Why would it sink?
Sir,
Sir,
because
because
it's
he's heavier,
more
sir. He has a
Yes,
more
sir.
density than
All right.
Gold
Not
is
only
heavier
because
than
it's
the
heavier, not only is it heavier,
gold
but
has
it
more
has a higher
density.
density. All
Yes,
right.
sir.
So anyone not clear so far?
No, sir.
No, sir.
All right, so moving on. Simply put, density is how tightly or
No,
stuffed.
sir.
Go again. All right. So simply density is how tightly or stuffed a material is packed together in a defined space. All right. So if we take the same volume, 1 cubic meter of foam, right, or 1 cubic centimeter of foam, wood, and concrete, we would see that each of these would have a different mass, right? So which one would be heavy? Which one would be the heaviest?
Sir, concrete. Sir,
All
Sir,
right.
concrete.
So the concrete would be the heaviest one, so therefore it would be the most dense.
Yes, sir.
And then which one would
Yes,
fall in the
sir.
center?
Wood.
All right, so the wood would fall in the center, right? And which one would be the lightest?
Sir, the foam.
Exactly. So the foam would be the lightest of all,
Foam.
but they would have the same volume. So they would take up the same amount of space, but it's just that the foam would be the lightest because the particles are the farthest apart. So they are have more space in between them in comparison to the particles in concrete. All right. Is that
Yes,
clear?
sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. So the concrete block is heavier and denser than wood, right? And
Yes, sir.
the foam block, because its particles are more tightly packed than the particles which make up the foam and the wood. So the concrete would be heavier than all of these, as we just said. If something is heavy for its size, it has a high density. So if an
Yes, sir.
object is light for its size, on the other hand, it will have a low density.
Yes, sir.
Yes, sir.
All right, so a pebble is heavy for its size compared to a piece of popcorn, which is light for its size. So imagine a big bowl of popcorn compared to a big bowl of pebble, or pebbles or stones. Which one of them would feel heavier?
The
Sir,
pebbles, the
Pebbles.
bowl of
All right.
pebbles.
So the
Bowl
bowl
of
of pebbles.
pebbles, sir.
Pebbles, sir.
Exactly. So the bowl of pebbles will feel much heavier because they have the higher density. Also,
Yes, sir.
a suitcase jam-packed with clothes and souvenirs has a high density, while let's say the same suitcase has balls and cotton, right? Which will
Yes,
have a much lower density than the
Sir, the cotton.
suitcase. Exactly.
Sir, the
So
cotton.
right, they would have a lower density. So size-wise, as it relates to size, both suitcases look the same, but their densities depend on the relationship between their mass and their volume. And this is what we essentially want to achieve for,
Yes, sir.
want to ensure that we understand this for today. All right, so let's say this is wood. In this one, we have wood. All right, and this looks, let's say this is a cork for a wine bottle. All right, you know those little cardboard looking corks?
Yes, sir. Yes, sir.
yes, sir.
All right, so the wood above, right, this wood here would sink further in the water. If you realize it sinks much further in the water, even though they're approximately the same size. So it would sink further in the water rather than the cork, because the particles in the wood are in the wooden block are more tightly packed. So therefore they are denser than those in the block made of cork. So you find out
Excuse me,
that.
sir.
Go ahead.
I have a question, sir. What if it was a sponge, sir? Would the
Right?
sponge soak up all of the water?
Exactly. So the sponge will not necessarily float. It will begin to float if you place the sponge on the water. Initially, it would float, but over time, it would basically soak up all that water. And then because it's soaking up the water, it becomes more dense. It will become more dense because it now has water inside of it. And then therefore, it will start to sink to the bottom.
Yes, sir.
All
Yes,
right.
sir.
Now, a box with more particles in it will be denser than the same size box with fewer particles in it. So this is box A and this is box B. Which is more denser?
Box A.
All right, so box
Box
A,
A.
all right, so more dense, sorry, more dense. So box A is more dense and box B is less dense. All right. So are we
Yes, sir.
clear on density? Do we understand density?
Yes,
Yes,
sir.
sir. Yes, sir.
All right. So water has more mass than an equal volume of alcohol. So the water is denser or more dense and weighs more than alcohol because the water molecules are more closely packed than the molecules of alcohol. So we can see this is the same volume. The alcohol and the water has the same volume in the cup. But on the other hand, we see that which one is more heavier?
The water.
The water.
Exactly. So the water is more heavier, right? So therefore, it is more dense than our alcohol. Similarly, water is more dense than oil because water molecules are are more closely packed than the molecules of oil. So if we place, let's say we place water, we place water in, this is water, and then let's say we placed, and let's say we placed alcohol on top of it. Then poured in alcohol. Let me go back. So this is our alcohol bottle, and we poured in alcohol, right? We poured in alcohol. We should be on the top.
Yes, sir.
Which one would be at the top, the alcohol or the water?
Sir.
The
Sir,
the
Sir, the
alcohol.
alcohol.
Why would the alcohol be on top?
Sir,
Because it has
Because
less.
it's less.
Because
So
this,
the water would be at the bottom, sir.
because the density of the alcohol is low.
all right, so the
It's not
density
as
of the
high.
alcohol is much lower than the density
Density of water.
of the water. So essentially, the alcohol will be at the top. Alcohol would be at the top, and we would have our water.
Sir, so to all the persons who like drink rum, sir, water is stronger than alcohol.
Right. So not in that way, right? It is more dense. All right, it is more dense. All right, so if the oil also is less dense than water, so you'd find out that oil would If you
Sir.
pour oil in a glass of
Excuse me,
water,
sir.
it will be at the top. Question?
That is why normally, sir, when I see people pour oil in water, sir, the oil just stays at the top
And why is that so?
because it has less density.
Exactly. So it has less density, so therefore it will stay at the top. All right.
I'll try that.
All right. So if you made a copper cube and you also made an aluminum cube of the same volume, so these are essentially the same sizes, right? And you place one in each hand, right? You would be able to feel that the copper feels much heavy, while the aluminum feels much, much lighter than
Can I
the
give an
copper.
example, sir?
All
Sir,
right.
so the copper is like the wire, sir, and the aluminum is like foil. The
Exactly,
copper
like foil
wire is
paper.
heavier than aluminum foil.
Exactly. All right. So one substance can have more mass per volume, therefore higher density than another based on the following. So atoms are the molecules of one substance. One substance might be a similar size yet have more mass than the atoms of others, right? So you might have the the molecules in, for example, copper being the same size as the molecules in mass, but yet they have in size, sorry, but yet they have a higher mass, which would cause them to have a higher density. Another way that a substance could have a higher density is that the atoms or molecules of one substance might be the similar mass, but smaller in size. So more of them might be able to fit within the same volume. All right. And
Yes,
then the
sir.
third one, the atoms or molecules of one substance might be arranged in a way that allows more of them to fit in the same way. So in the case of copper and aluminum, their atoms are arranged similarly, but copper atoms are smaller. So therefore, you are able to hold more particles. Therefore, they have more mass than aluminum atoms, giving them a higher density. All right. So I would go ahead and
Yes, sir.
let me create another slide and try to explain this. Let me try and explain this much better. All right. Just give me a second. Let me take this out. I'm going to try and
Do you
explain.
know that they have COVID-19 vaccine, sir?
All right, that's not what we're talking about today, all right? That's not what we're talking about. We're not getting involved with that today. All right, let's just try and finish this. Get rid of this. Here.
Lala. Hello. Yeah.
Sir, so you might not mute.
I know.
All right, let's see if I can explain this a little bit better now. All right, are you seeing it? Oh, wait, give me a second.
Yes, sir.
Yes,
Yes, sir.
Yes, sir.
Adjust this. All right, so one substance can have more mass per volume, which would mean that it has a higher density than the other based on the following. So, as I was trying to say, atoms or molecules of one substance might be the similar size, right? So you might have the same block of aluminum, let's say this is copper C and aluminum A, and they have the same amount of molecules. 2, 3, 4, 5. Let me get rid of. Let's just say we're comparing two atoms or two substances. 1, 2,
Yes,
3,
sir.
4, 5. These two would be, let's say that they are the same size, but this one might be heavier. These molecules might be heavier. That would give them a much higher density. On the other hand, atoms or molecules of one substance might be the similar mass, but be smaller. So you have one molecule here, or one substance here, and they have much smaller molecules in comparison to this one, which has much bigger molecules. And these molecules, the small molecules and the big molecules, are the same size, or same mass, right? Same mass. And this is able to hold more. So that would cause this one to have a much higher density, right?
Yes, sir.
And the last one is that
Yes,
atoms
sir.
or molecules of one substance might be arranged in a way that allows them to fit more in the same volume. All right, so let's say this is copper, or let's say this one looks like this. All right, we have some squares, 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 right? This is able to hold more because they're arranged in this way. So this one has 5, and this one still has 5, but they're not able to arrange them properly, right? So that would cause them to not be able to hold more. But because these ones are in a way that can hold more, or they're regular shaped, right? They're able to hold more. This would cause them to have a higher density.
Yes, sir.
Yes, sir.
All right. Are we clear so far?
Yes, sir.
Yes, sir.
Yes.
All right, so this is the last thing. As we saw, this has the same mass as this one. But these are much smaller, so therefore you are able to hold more. All right, so these are much smaller than these, so they're able to hold more. All right, so we'll do some calculations. I do some calculations now for the final thing for today. Do you remember the formula for density? Let's go back to that slide. Remember the formula for density?
Yes, sir.
What is the formula?
Sir, can you repeat?
Sir, can you repeat?
What is the formula for density? Right here. Are we seeing this?
Yes, sir.
The formula is what? Mass over what?
Mass over volume.
Over volume. So say we had an object with a mass is equal to 2 kilograms, and it has a volume of 1 meter cube. Or let's say this is at 4 kilograms. 4 kilograms, and let me change this to 1.5 meter cube. How do you calculate the volume? It would be density. Density. How would you calculate density? It would be density equal. What is the mass?
Mass
over volume.
So what is the mass here?
4 kilograms.
4.
So the mass is 4 kilograms. And what is our volume?
1.8.
1.5 meters.
All right, so 1.5. So therefore, the density would be equal to what?
Sir, the density would be equal to 5.5.
All right, so the density would be equal to 5.5.
Kilograms.
Are you sure? Check it on a calculator.
Bring out the calculator real fast. Camera. Sir, it says 5.5.
Sir, mine says 2.6.
All right, so for the person who said 5.5, you want to check that again, right? Don't multiply them, divide them. So
Yes.
it is 4 divided by 1.5.
2.6.
Yeah, so it is 2.6. All right, so it
Yes,
is
sir.
2.6.
6 continues, sir, so left us 7 at the end.
All right, so let's
Sir,
put 7 at the end.
2.67.
Sir, and I learned this in maths, sir. When a number goes on continuously, sir, you can put like a stroke on the top, sir, to indicate that it goes on and on.
Okay, that's good. That's good. But for now, let's just round up. All right, let's just round up for now. All right. So the unit for density here would be kilograms per meter cube. All right. So the unit for density equal kilogram per meter cube. All right, or this could also be kilogram per centimeter cube. All right, so it can be either. It depends on what the volume is in, all right?
Yes, sir.
All right, so everyone clear?
Yes, sir.
Yes, sir.
Anyone doesn't understand?
I understand, sir.
All right, so that is it for today. If anyone has any questions, you can go ahead and ask.
Going to get classwork.
All right, so I'll send classwork for tomorrow. We won't do any classwork today. And then this call will go off any minute. All right.
Okay.
Sir, are you going to send the notes in Google Classroom?
All right, I'll send it in tomorrow. Tomorrow, remember, we have class tomorrow again, all right?
Okay, sir.
Yeah, so take the time and read over this.
Excuse me, sir. When you send the notes